Hey class, here I am again to give you guys some helpful pointers for problem number 43. It's a tricky one and I've gotten a few questions on it already. So on this problem you have the skateboarder here who's moving with some velocity, which we'll go ahead and call v1, and she goes and she jumps to some height h that you're asked to determine. And we're also told that as she goes jumping off of the ramp here at some angle theta. And you're also told that the ramp height is some h value that is also given to you. So I'm going to use lowercase h for the ramp height, and then the capital H you see up here is the height that you're trying to determine. So in order to evaluate this problem, I'm going to be using conservation of energy. And to do so, I'm going to realize, and I realize now, and you might not necessarily know this when you first start, but you will as time goes on, but that you're going to have to evaluate this problem looking at three different points in time and in her path. Point 1 is down here when she's on the flat, horizontal, level ground. Point 2 is right here as she's taking off the ramp, and then point 3 up here at her apex. At each of those 3 points, she has a velocity, so we have v1 down here, there's a v2 here as she's taking off the ramp, and at the apex she still actually has her horizontal velocity v3. A lot of times people miss this velocity saying she's at her apex, that means her velocity is 0, but only her y velocity is 0 at that point. She still has her x velocity up here at point 3. Okay, so to get started, if you wanted to solve this problem, kind of the typical way that you might think about it is looking at conservation of energy. And the thing that you might want to do when you aren't sure if you can solve it or not is to say, okay, let's consider going from point 1 to point 3. See if the information we're given is enough to solve. So if we look at the conservation of energy from point 1 to point 3, what the conservation of energy equation would look like is that kinetic energy at point 1 plus potential energy at point 1 plus any work done by non-conservative forces is going to be equal to the kinetic energy at point 3 plus the potential energy at point 3. So, as we know from our problem, we're probably going to use this point down here at the bottom as our 0 point. Okay, so that means if that's our 0 point, that our potential energy at point 1 is 0, and since she's on a skateboard, there's not going to be friction. We can assume air resistance is sufficiently small, so that means the work done by non-conservative forces is also 0. And so what your equation turns into, or reduces to, is your kinetic energy, so 1/2 mv1 squared is equal to your kinetic energy at point 3, so that's 1/2 m v3 squared, or excuse me, not v cubed, v3 squared plus your potential energy at point 3, which is mass times gravity times height, but the total height at point 3 is this entire distance here, so the total height is going to be the little h plus the capital H. So if we look at this problem here, capital H is what we're trying to find, little h is given to us, we know g. Oh, look at this, we see that all terms have mass in it, so that can cancel out. And so we're left with then an equation, v1, v1 is also given to us, but we want to find capital H, but we do not yet know what v3 is. So we can rewrite our equation for later use. 1/2 v1 squared is equal to 1/2 v3 squared plus g times h plus capital H. But in order to solve, we need to determine what v3 is. So if we look at or think about what's going on in our problem here, we can observe that we know during this portion of the journey here, that is the parabolic motion, the projectile motion, we have an object that's in free fall, the girl that is just experiencing gravity only. So what that means then is that V2, if we think about its components, like its x component here, I can call that V2x, its x component is going to be the same throughout the entire journey. So what that tells us then, maybe I'll make a note up here in the corner, that our V2, or our V3, excuse me, maybe I'll use it in red to stay consistent, our V3 is just going to be equal to the x component of V2, since there's no acceleration in the x direction for something undergoing projectile motion. So, if we think about the component form, once again, looking over here at our V2 that we have going on, our V2x should just be equal to our overall V2 multiplied by the cosine of the angle that we're given. So we can rewrite our equation for V3 and say that it's going to be equal to V2 multiplied by the cosine of theta. So what that means is if we can figure out what V2 is, then we can determine what V3 is by just multiplying it by the cosine of the angle given. So in order to figure out V2, let's come down here in the new space that we have now and evaluate what's going on from point 1 to point 2, because guess what, with conservation of energy, another reason why I love conservation of energy is because you can evaluate it between any 2 points in time and space. So we already did points 1 to 3, but now we can look at points 1 to 2. We could even do points 2 to 3 if we wanted. So looking at points 1 to 2, once again we know kinetic energy at point 1 plus potential energy at point 1 plus work done by non-conservative forces is going to be equal to kinetic energy at point 2 plus potential energy at point 2. So we already have established that potential energy at 1 is 0, work done by non-conservative forces is 0, so once again your equation should look like 1/2 m1, or well the m stays the same so I don't need the subscript, m times v1 squared equals 1/2 m v2 squared plus mg times the height at point 2. So we glance at our picture just to confirm the height at point 2 is just the lowercase h, so mg times lowercase h. Once again our masses can be cancelled out and you're left with an equation that has v2 in it, which you're trying to determine, and the only other terms are v1, which is given to you, h, which is given to you, and g, which is 9.8. So solve this equation here to determine what v2 is, and once you've solved this for v2, you can go up here, figure out what v3 is, and use v3 in order to solve for that height. Crazy problem, pretty tricky, but I know you guys can do it, and I hope this helped. Have a good weekend. A box-worthy weekend.